Embedded System Communications. I'm Mustafa and I'm Hardware and Software Engineering. In this lecture, I describe sending data between the embedded systems in C programming language. The features of the C programming language are used to structure the data. The data structure is very important to send the data safely and reliable. In a hardware, data is transferred between the embedded system A to embedded system B by some protocols such as USART, CAN, SPI, or RS485. But our main focus in this lecture is how data is structured. Data can be sent in a bulk of the bytes sequentially, but this method is not safe. The better way is put the data into the frames and the frames sent to the devices. At the first, I constructed a simple frame and then described the ways data can be put in the frame. These ways can be utilized in similar situations. Consider the simple frame here. The byte 1 is the starting of the frame. Any sequence of the bytes can be used in the starting of the frame, but considering, for example, 18 in a hex is enough because the transferring process is synchronized and the device A sends the requested frame and the device B receives the frame with starting with the specific byte and then check the validation of the frame and then make a response and return to the embedded system A. So consider that 1 byte is enough. The second byte is the address of the client or slave device. Consider that there are many clients that you want to send the data to the specific client. In this way, this byte can be used to determine the client. The byte tree is the size of the frame. It can be up to the 256 bytes. For sending more than 256 bytes, considering 2 bytes as the length. The length of the frame is required because the slave device should determine when stop reading the bytes from the hardware interfaces. The byte 4 and the up is the start of the data sections. In this lecture, we will focus on structure this data, structure the ways that how we can make and put it in the frame. The byte n on the last is the checksum or CRC byte. The checksum is the sum of the bytes in the frame and it is used to validate the frame. So, we will go to the code in the Visual Studio 2017 and try the programming or review some advanced topic in C. I create a console application and I start to construct the frame and send it and then dispatch to this frame and extract the data. Okay, consider that you want to send a tree. You want to do 3 variables. Two 32-bit or the 4 byte into unsigned integers and the 1 char. For example, consider that we initialize the var1 set 0x 10, 12, 30, 40 and the variable 2 0x AA, BBCC and DD. Now want to construct a frame, construct the sending frame. So as I got your in a 32 is not defined. So include the std in it, std in it, include the stdio, stdio.h, and then include a string here. unsigned char pointer constructed frame called um, unsigned char store malloc. The size of the frame. The size of the frame will be here. Size of frame is one for start, one for address, one for length, and the size of the data 4 plus 4 byte plus 1 byte and the 1 byte for checksum CRC. Look, frame, consider the constructed frame. The first byte is x18, constructed one is 10 hex. For example, the address is 10 hex to the size of the frame. And the constructed frame 3, we did a start of the now we construct the data. Okay. For this, character 4 and temp 0 can be var1 and suffix ff temp 1. I consider that I want to send and I want to convert it var1 to the sequence of bytes. It can be done in a big endian or little endian. var1 shifted 8-bit then and ff and for temp 2 and the temp 3 16 and the 24 2 and 3 and then memcpy constructed frame plus 0 and temp and the size of the 4. Now we will fill the first for the second on 2 bytes 1 var2 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 and var2. Then memcpy plus 4 and then the third var3 is constructed from 11 to the var3. And for the checksum, we can calculate the simple checksum. Consider that init sum is 0 for init I equals 0, I is smaller than the size of integer, size of the frame minus 1, I plus plus, sum equal constructed from I. Now the frame is ready. Now we consider that we send the frame. Now in a device B, the frame is received and check the checksum for frame validation. Now we want to extract the extract the data from this the frame. We could do this. Unit 32, receive data, receiver 1, called 0, unit 32, to receive var 2, called 0, and the car receiver 3, called 0. So receiver the var 2 is constructed from 0 plus constructed for the shifted left 8-bit 8-bit. Assume that convert the byte. Okay. And this 4, 5, and 6. Okay. 16, 24. This construction have a problem. You can compile it, but this should not be minus. It should be or. And you know that it's converting, patching, dispatching data can be source of the bug. We will improve this during this lecture. And rest for survival 2, 7, 8, 9, and 10. Okay. And about the rest, var 3 equal constructed the frame 11. We do not consider the checksum because it was checked before in the device B that will receive the data. Now printf 08x var1 var2 var3 res var1 res var2 and the res var3. Okay, want to read it. The print version should be the same as the initialized variable. We compile it. Okay, you know that the received data is okay. Now, but you know that if you have any 100 variables, it's really hard to patch and dispatch the messages. One further improvement that we do not want to involve this calculation because this calculation can be source of the bug. So we will use onion that when we want to converting it unsigned 4-byte and signed integer to the sequence of the bytes, the onion can be used very good. Type def onion converting data UNT var1 and char var2 because the space of these two variables is the same. When you fill var1, it automatically fill the var2. converting this, just do this. Sending data, converting data, converting data, var, converting data, converting data, dot var1 equal var1. Just for filling the constructor with, use converting data dot var2. It's enough for this. And for second one, use this var2, and for this one, use var2. It's enough. For reversing, you just do this. memcpy converting data dot var2 constructed frame plus 0 and the number of the 4 bytes, and then the rest underline var1 equal converting data dot var1. That's it. And for the next should comment this. Convert data plus 4. And the rest too. Now we will compile it. You know that the var1 and the var2 is correct. But consider that if you have more than 2 variables, just like in a number of 100 variable, 100 parameters, and if you want to concern about the indexing of the variables in the constructed frame, you know, it's source of bug. And on the other hand, for example, when you write the codes for example, 15 parameters, when you want to change one variable, for example, changing the type of the one variable from the 4 bytes integer to the 1 bytes unsigned char, you will write the whole code and debugging your code as a whole. And you know that you will put into the trouble. Now, I want to describe a new method to using the structures that converting the data and the patch and dispatching the data is the responsibility of the C programming language. So for this, at the first, we will convert construct a frame in a function. It will be very good to use the functions to construct the frame. So unsigned char star constructing frame. The first one char store the input, the second one init and equal the size. Equal the size of the frame. Okay. Char function definition. Okay. Now we'll copy this. So use the size of the input. Consider that when you input the sequence of the byte in the input of the function, we consider that send the size of the input in the second argument. You know, because if you consider that the input as a string, yes, it's okay. When you get a str length of the input, is equal to the length of the input. But consider that there are many zeros in the input, the sequence of the bytes. In this order, when you use strlength, you do not catch the size of the input, and the size of the input is incorrect. So in C, please send to the function argument the size of your character pointer. Okay? And for constructed data, memcpy constructed frame plus 3 input and end. And finally return constructed frame. Okay. Now we want to construct a data structure. So we type def struct sending data and 32 var1 unit 32 underline ty2 and a char m the var3 and this sending data. We construct these structures and we will use here sending data, sending data call 0x10 12 34 a bbccdd, and the last one is m. We want to send these structures. It just need to get a pointer of unsigned char of the sending data and fill the constructed frame. That's it. So memcpy or we have functions. So unsigned char frame equal constructed frame. The input is for char star, the pointer of the first element of the sending data, and the size of sending data. Okay, it's good, but star. Okay. Now we just construct the frame. Now send it and check it in device B. Okay, now we want to dispatch this data very easy. Sending data, pointer, for example, p receive data, equal sending data pointer from the start of the data is frame plus t. Now we will print of here, and you know that instead of that ps data var1 var2 and 3. Be sure that the free of frame. Don't worry about it. When you create the memory, when you create a variable in the memory, in the heap memory, we consider that when you create just 3 of them immediately, because it's source of the memory. And I will use while1 for while1 to stop it. Just sing data. Oh, yeah, okay. You know that very easy. You know that we just writing 4 bytes of code. We have done all before. It's just one line. When we want to change the sending data, for example, adding 5 more variables, this code is not changed. So you don't worry about how to make a data and put it in the frame. These techniques can be used in many situations, not only transferring a data. So try to use it in your code. There are some important issues. For example, the size of sending byte. The size of sending byte, because you have a two 4-byte integers and a 1 char, the size of sending data should be 9. But in the debug, you will see that the size of the data is not 9. It's 12. You know, it's 12. Why? No, it does not depend on the C program or the C compiler. It depends on the hardware architecture. The microprocessor fetch from the memory 4 bytes. It's a line of the 4 bytes. So the number of the bytes that you have fetched from the memory is product of the 4. So the size of the sending data will be 12. You can consider some reserve word here. For example, char, reserve, reserve 0. You know that when you compile this, the size of the sending data will 12, will not change. No, it's 12. Consider that the first one. The second important issue, these technicals can be used when you have a variables static. For example, when you want to send some variables, dynamic variables, such as some messages that have a variable length. This technical is not effective. Consider that when you have 100 messages, if you want to consider the length of each message up to the 50 bytes, you should send about 5,000 bytes to the embedded system B. For example, you're using UART. You're using serial port with a baud rate of 9,600. It takes about 5 seconds to send the data. This data is redundant. So, you should change this structure to support the dynamic structures. If this lecture is helpful to you, encourage me to continue to support the dynamic structures, to support the survival. You know, at that time, you you should work more. You cannot done this. You cannot done this with the 2 line of the code. But that way, you're sure you write for the first time and debug it, and then using in other parts of your code. Thank you so much. Please comment me if you have any questions to zavata_afan at gmail.com. Thank you.